Thanks, Christine, and welcome, panelists. Thanks so much for joining us here.
May I? Yes,
Go
thank
for
you.
it.
I'm happy to wrap up the last session of the day. So first, I'd like to start, please introduce yourselves and share a little bit about your current role and the overall mission of your organization. Why don't we start with you, Ginny?
Start down at this end?
Yeah.
My name is Ginny Savasco. I am a chief technologist at Booz Allen Hamilton. I do like to point out a chief technologist, not the chief technologist. I support our Booz Allen's work in support of national intelligence agencies, located mostly in the Washington, D.C. area. And in particular, I manage a portfolio of contracts where we're applying Cloudera and other big data tools and data analytics tools to merge multiple kinds of intelligence and more rapidly advance our ability to extract value from the data that the intelligence community is collecting.
And I'm Brian Fox. I'm with USGS and the mapping organization within USGS. Our primary brand is the National Map. So we provide free geospatial products, data, and services to the public to support everything from science to recreation. So if you buy a National Geographic map or any of those kind of paper products, or a lot of mobile applications, including Google and the like, use a lot of our data to enable their operations. And at USGS, I support the organization by leading a terrific group of software developers. So there's about 50 folks that work for me that enable the national map. So that's what we do there.
I'm Jawad Khan, Director of Data Sciences and Knowledge Management at Rush University Medical Center in Chicago. I direct both the business intelligence and the data science side of the work at the university. Have about 20 people in my team, 5 data scientists, a whole lot of report writers. We are actively, like day-to-day tasks would be engaging in providing business insights, business intelligence type of work to the hospital, both on the clinical side and also on the operational side. And we are also engaging doing a lot of data science work with respect to predictive analytics, big data work that I think Nick touched upon a lot of things, and we'll get into this as we get into the discussions.
Great, thanks for the introduction. So let's get started. I'm going to start with a general question, then I'll ask more pointed questions to each of you. So how is your organization using data and analytics to support your mission? And we'll start with you, Jawad. Could you talk about where you are seeing enhanced and improved mission effectiveness with data within the health services community?
Sure, that's a very open-ended question. So we can talk, like it needs a session by itself to talk about how healthcare is using analytics today. But the opportunities.
Sounds like we have our next topic for our
sure,
next
definitely.
event.
So there are plenty of opportunities. Obviously, healthcare is not as fast as adopting technologies as other verticals, but we have seen tremendous growth in what we are doing in the last few years, specifically with the introduction of big data, machine learning type of work in the healthcare. At my institution, we are primarily focused, like I said, is on doing a lot of predictive analytics. We are able to take the data, clinical data, run it through machine learning models, and be able to predict, for example, if any given patient would have a higher chance of coming back to the hospital as a readmission. Readmissions are a big deal for the institutions. So we would always want to predict which patient is more likely to come back to the hospital with the illness, right? The second would be to monitor our ED. ED is such an important aspect of any healthcare institution that making sure that it is flowing efficiently, there is enough capacity to take the people is very important. So we have used a lot of analytics and data science work to be able to create a command center, if you may, for the providers to be able to see what the workflow is, how efficient the ED is functioning, are resources adequately sourced, literally from a touch of a finger from their offices. This was not possible just a few years ago. And one last thing before we get into other discussions is we are using a lot of technologies and sensor data from the bedside instruments now. All these instruments are very active. They're collecting patients' information. Before, this information was siloed, but now we are able to bring all this information from the bedside monitoring systems into a single source to be able to, again, predict what the conditions of the patient would be going forward. A huge topic, like literally we can take each use case and talk for a long time about this, but I'll be more than happy to, on the sidebar, take any other questions.
Sounds like you've already hit that transformation part of your journey with all of the different use cases.
Yeah, we have. At our institution, we have implemented a HDFS environment. Obviously, it's a Cloudera distribution. We have also implemented a data lake. Our data lake is in Azure Cloud. We have already done that, to answer your question. Yep.
Wonderful. Brian, let's go over to you here. I'd love to hear how USGS in your office, the Technical Operations Center, is using data to improve services and the quality of work being done.
Absolutely. So at USGS, we've been, and within our mapping organization within USGS, we've just been transitioning to the cloud over the last year and a half. There was a number of reasons for that. So we're a bit behind the power curve, but we're learning pretty quickly. And as far as data to help drive decisions, it's interesting over the last year and a half, it's not been so much the quantitative as the qualitative, that we'd understand that our ability to deliver data, products, and services would just be a heck of a lot better from a cloud provider than from our internal, legacy networks. But with that, there was a fantastic concern over the cost to us, because as people would download data, it was going to get a lot easier, and it would the bill would come to us, and it was no longer a fixed cost, but it would be completely variable and scalable based upon the public's access to our data, our elevation, hydrographic, and other topographic data. So as things would get easier, we would be picking up the bill for it. So there was this rightful kind of lack of information going into it, but we knew it was the right thing to do. And now as we've transitioned and data is being delivered from the cloud, and our cloud provider came from the Bureau, a Bureau level contract with AWS, it's caused us and forced us to look at our current business model. For years it was anybody can come and get as much data from us for free. It's free and available to the public. It's not classified like NGA data. It's just come and get as much as you want. But now it's so easily available, with the fear of somebody just coming and pulling all of the 3D elevation data for the entire nation and running away, and we getting the bill for it. We're looking at and starting to use metrics now of how much is being downloaded, how much is that costing us, and using that to understand how we need to tweak our business model so that users that are looking for really large data sets, they're working with Amazon on that, so it's not as if USGS is going to hand them a bill that they need to pay, but for that, to transition data from one S3 bucket over to another, they work with AWS. So data right now helping us, and those metrics and analytics helping us understand how we need to adjust our business model because of the disruption of the cloud. So it's all a good thing, right? But causing some tremendous discussions at our headquarters level as far as how we need to adjust our business model.
So data is in fact becoming a truly valuable asset for you and your organization.
Absolutely, and it's driving some major decisions as far as just overall business model for the National Geospatial Program.
Great, thank you. And Ginny, over to you. What kind of data are you collecting, and where is it coming from, and how do you support the volume of data?
So most of the data we're dealing with is streaming data, and we're getting a lot off of sensor platforms, off of different satellite platforms, off of airborne platforms, both manned and unmanned, off of camera footage that's coming from a variety of sources. We are blending in things like Brian's sources that tells us what the geography looks like. We are using a fair amount of open source information, and also some traditional government sources that provide information about where ships and where aircraft are and are constantly updated. And so, as you can imagine, there's more and more of that data available to us. And historically, the intelligence community has built exquisite systems for a particular sensor type. So for a particular satellite platform or a radar platform, all the way from the platform all the way down to the consumers. The systems were really tailored, and they were actually pretty good at that mission. The problem is that we don't operate that way anymore, and those exquisite stovepipes really locked the data inside. So a couple problems. Can't update them as the world changes. And you can't move across different data types to see patterns that require insights into multiple kinds of data, right? That where is what you're collecting off the satellite plus what you know about the geography plus what you know about where the trucks are. How does that add up to something? So volume has been a huge challenge, and I think because of that, the intelligence community was pretty early to go to the cloud. Because not only do we have big volumes, but it tends to be surgy. So there'll be more, a world event will occur, and then there'll be more data of particular types, or analytic demand will rise, there'll be more of different types. And so we have found that using a cloud infrastructure has really enabled us to actually do that promise of on-demand scaling, so that when we need additional resources, we can pull them in. We've also leveraged some machine learning kinds of activities because there's a lot of data, but not all of it is as valuable. And so to begin to sort through some of that in the way our human analysts used to do, we're actually deploying machine learning tools that can do some of the more rote preliminary stuff to take that load off the human beings.
Great, thank you. So, Chairwood, I wanted to ask you, you talked about readmissions. We hear about that, huge problem, very costly, obviously has an impact on folks' health. And you also talked about managing workflows and having access to new telemetry data from bedside monitors. What are some of the predictive areas that you see going next?
Good question. Predictive in terms of not just the technology of doing predictive analytics, but looking ahead of technology and what technology can provide to the healthcare. One of the things that we are now experimenting with is to be able to make analytics completely voice-enabled. So a provider, you need to take away the keyboards from the provider. Provider should be able to interact with the patient, and at the same time, we want to be able to collect the data and the interactive session between the patient and the provider without either of them touching the keyboard. So now there are a lot of bot technology available. These are all connected to the big data sources. We are literally experimenting with that, where the provider would be speaking, and we would be not just recognizing who's speaking at the same time. Obviously, this is being done in the ambient rooms, but we are able to take that data, parse that data, store the data in the proper place, and at the same time, in real time, be able to use the data to provide insights to the provider based on the interaction with the patient is having. So this is really cutting edge. It hasn't been successful in the sense of that we have productionized it, but we are definitely experimenting, and we are seeing some very good results with voice analytics. The other side of it is, this is the provider and the patient side, but also on the business intelligence side, the CEOs and the CFOs are asking for more and more analytics to be available, not at the fingertips, again, also at the voice command. They want to be able to come and sit in their office and speak to Alexa sitting on the desktop to say, what is my ED volume today? How many open beds do you have in the hospital? And Alexa should be able to speak back and say, this many volumes available, such and such things are available. So that is also possible. There is technology that is out there that we are still testing. Very, very interesting, quite a bit of interesting. So there is a lot of voice enablement. There is a lot of predictive analytics. There is a whole bunch of machine learning models that have been developed now that have matured quite a bit in past. And we are bringing all that into our institution, or at least trying to bring them into the institution to improve healthcare.
Makes a ton of sense, especially because everybody knows handwriting and typing
Oh,
are
yeah.
just, very slow.
Again, so once we get into more discussion, I can describe one more use case that we do with the Clinical Documentation Improvement Project, where voice technology directly blends in, and I can talk about that as well.
That's great, that's great. So Brian, you talked about the push to the cloud, and you kind of mentioned two angles to it. One was the expense, which I'm glad you mentioned, because a lot of folks just naturally think it's going to be less expensive in the cloud, and it's something that needs to be actively managed. And then you also talked about your changing business model. Can you just expound upon those a little bit and talk about the use cases that pushed you towards the cloud? Was it because some of your data was originating there, or was it bursty types of analytics? What was kind of going on in that space?
Really just the opportunity to make getting our data easier and making it much more cost effective for us. That in the past, purchasing hardware, servers and the like, it's a sunk cost. And over time, the capability just degrades. And not as it's just a sunk cost with the actual equipment, it's also a sunk cost in time and energy spent for procurement. And anybody in government knows how costly that is. Whereas with cloud, you want to talk about what you need today or this minute, you can automate that. So it just pulls a lot of people out of that very expensive process, because it's typically senior people from an IT or development standpoint that are typically a part of a procurement process or discussion. Lots of meetings and lots of time associated with that. So that's really what, from a bureau and from a center standpoint, what was driving us, the notion of getting what we need when we need it, and allowing the public and scientists and those that rely upon our data to help drive their company or their startup, making it a heck of a lot easier to do just that. As far as, I talked a little bit about how our business model is requiring some adjustment because of that ease of access of data, and that's just on the delivery of our products, data, and services, our geospatial products, data, and services. We're also, we just moved a production capability where we have one map product called US Topo, if anybody's familiar with the USGS topographic quads that have been created for decades. Just a few years ago, back in 2009, we started making those again, but with a lot of automation. But that was on our internal servers, and we re-engineered the technology associated with that. It's called print on demand from Esri, and we implemented that in our AWS cloud. So the notion of doing that without going through the procurement process associated with getting those legacy servers sitting in your footprint. And then one other terrific opportunity, which is as far as metrics, right, and moving faster for the organization's benefit and for the user's benefit, is really cloud enabling the potential for DevOps for us. So just over the last 6 to 9 months, we've been experimenting with doing more and more development in the cloud, and we're starting to see, and we're starting to demo to some of our senior leadership the notion of we can release not just once every 2 to 3 months, but once every 20 minutes, and just how revolutionary that is. And so that's just a couple use cases we're seeing as far as helping us to push in that direction. So the notion of more data faster and easier to the user, the notion of getting our internal production capabilities up to the cloud so we have exactly what we need when we need it for our geospatial production capabilities, and the notion of enabling our development and IT staff with scalable capabilities.
Are you finding that some of the data that you're dependent upon is originating in the cloud? Is it coming from applications or service providers?
Not yet, but we're looking at that. So the notion of moving more and more production capabilities in the cloud, because it'll probably just move over from one S3 bucket into ours, and then guess what? The people who are consuming our data will do that too. So the notion of moving more and more in that direction.
Ginny, it looks like you want to pop in here.
I wanted to comment on the cost question. As we've moved systems to big data, particularly Hadoop ecosystems, and in the cloud environment, I believe that they are definitely less expensive, but it is sometimes hard to prove that because the way we price is so different. So when you go to an Amazon platform, for example, you basically pay, right now you pay by the hour unless you're reserving instances for a year. They're going pretty soon to like a by the second. But at the end of the month, you get a full bill, and it is for all of your AWS usage. And that can look like a big number. And when we look at our legacy hardware, our legacy data centers, it's very hard to figure out what that costs per month, because the hardware was procured some time ago on another vehicle. There's staff there who manage it, but their costs are hard to uncover. And so we've had people say, moving to the cloud is more expensive. Look, I get a bill at the end of the month for $60,000 or something. And it often takes some archaeology to actually go back and substantiate, yes, but your current data center is costing you $120,000 a month. And so on the surface, people will say, that hardware is already paid for, this is a net plus. And we've had to do some work to really uncover what the truth is and show where the ROI is on moving to those environments, even absent the ability to scale.
And that's what's interesting, is cloud is terrifically transparent. You get a bill for exactly what you're using, and the legacy, is not. It's buried. It's difficult to understand what those IT resources are costing you on a by second, notion. Let alone even an annual standpoint can be difficult to uncover completely.
Yeah, J-Rod.
Yeah, I mean, one thing to remember with cloud is a service. So everything comes as a service. The data storage is a service. The compute is a service. The fact that you will be using the bandwidth is a service. So what happens is, I think Jeannie is right in the sense that the institutions already have sunk cost in the infrastructure. So at my institution, we already have X number of gigabytes of pipeline already established that we were not paying to send and receive data to people, right? But once we move the data to the cloud, we are not even charged for the data storage, but also we charge for the service. And then for anything you do, you're being charged for the specific service that you're using. It's the mindset of moving away from operational costs to basically service costs is what we need to think of, right? That's the distinction. So it depends on the institution, it depends on the culture of the institutions, but there is definitely a good use case, or only time can tell if the total cost of ownership in the cloud is cheaper than on-prem. I don't think anybody has claimed victory yet that cloud is cheaper, but it is definitely something that needs to be looked at more closely. Again, the important thing is to remember that cloud is a service. You're paying for the service for every unit of the service that you're utilizing.
Thank you. Hey, Ginny, you were talking about kind of organizing differently, and I know that you have something called the SCAPE framework. Can you talk about that and how it might be used across the intelligence community or across the industry?
I love to talk about SCAPE.
Okay.
I'm glad you asked. Secure, cloud-based analytical processing environment. SCAPE is a framework that we created. It spawned originally by some internal Booz Allen research. We matured it through a couple of big client activities, one at the National Geospatial Intelligence Agency, Brian's old agency, a second one at the National Reconnaissance Office. And then we recognized that there was, we thought, more value to this for more general use cases, and we brought it back in-house and created a more general purpose architecture. Our concept there were three things we were primarily trying to achieve. It is a Hadoop ecosystem. We run on a Cloudera because that's been a very valuable path to get things deployed quickly. So first, we wanted to make it really easy to bring in new data sources. That's a real handicap of the current systems. And we wanted data owners who understood their data but were not programmers to be able to do that. So we deployed some technology, mostly based on Niagara Files, NiFi, that allows data stewards to basically automate that ETL process and get their data in quickly. And when I say quickly, I mean in a day or two, and not the months that it might have taken previously. The second thing we wanted to do was make all of the data in the system really discoverable to human beings and also to other systems. The idea is anybody can bring their data, and any third party can leverage an application or an algorithm against the data. So we were trying to basically turn those historical stovepipes on their side and open this up to everybody. And then the last piece that we've added in, which we think is really exciting, we are processing mostly streaming data. And so we have created what we call the context-assisted processor that takes what we know based on the data that's in our data lake and applies that to the data that's streaming in to make faster decisions about what data is relevant and what isn't. So for example, if we're looking at data about what ships are going in and out of port, we can use what we already know about their patterns of life and typical activities that they engage in to more quickly decide if somebody is doing something, if a ship is behaving in a way that is unusual and one of our analysts would want to know, or we would want to tip another one of our platforms to do some additional collection. So to give a more concrete example, ships, when they are on the ocean, when they're fishing, they generally exhibit a very particular pattern of moving through the water. And so early on, we had a use case that identified ships engaged in this pattern and combined it with information we had about who had licenses to be fishing in that area to flag ships that were fishing illegally. And that was really successful, and the Coast Guard was really happy about it. But criminals are really smart, and so pretty quickly they figured out, maybe they didn't know exactly how, but that if they did this pattern, the Coast Guard would be by quickly to check on them. So they started doing other patterns that were a little different, but still suggested that they were illegally fishing. And so using the strength of the computer to look through all the kinds of patterns that ships engaged in and all the arrests that have been made for illegal fishing, the system started suggesting other patterns of ship movements that also suggested illegal fishing. And so even the criminals, even when they were trying to be clever and hide their behavior, the system was able to alert Coast Guard to go investigate what was going on.
Now, do you have plans to take that framework and make it more broadly available?
So the beauty of it is it's designed to be really open already. We think openness is really the secret sauce of getting the most out of these big data architectures. And I mean truly open.
The open and secret, that's great.
Well, it's funny, the data's secret, but there's nothing secret about the architecture. That's the beauty part, right? So we want it to be wide open. We want to use open source so we can take advantage of the overall community of providers. We want to be able to swap out components when better components come in. We want to make sure our clients don't get locked in with a vendor, even us, that is no longer providing the maximum value. And we want to make sure that other players who maybe aren't as big as Booz Allen, but have a great idea about a particular algorithm, how to find, how to track opioid use, or how to identify the spread of flu, or whatever, they can bring their algorithm, and we're providing a way for our government and all of us to leverage what they know, their very specific expertise, without having to understand the whole infrastructure behind it.
Well, that's great. Thank you. So you, Jared, you talked about having another use case. Is it in the area of machine learning?
Sure, we have, yeah. So in machine learning, well, let me just give you the background of healthcare. It's interesting that in healthcare, we are asked to provide quality by keeping the cost down. So there is a negative correlation between quality and cost. In other industries or other verticals, if you provide more quality, if you go buy a house, the more things you put in the house, the more expensive it is. So the quality directly drives the cost up, but in healthcare, it's the other way around. The expectation is to provide the best quality of healthcare while keeping the cost down. So how do we do that, right? Again, now it is possible to look at this data more closely to understand how to improve clinical workflows, how to get in front of the patient before, so being a little bit preventive as opposed to being doing it after the fact. So machine learning is enabling us to do that. And one use case I want to use is we are very engaged in doing adenoma detection rate. So if a patient comes in, so for example, for colonoscopy, right? It's just a screening, it's a measure. We would want to do colonoscopy after 50 years for a patient every once a year. But now we are able to not just do that in a traditional way, but also look at the data and identify the markers. And if the patient is interested in doing precision medicine, we would be able to take the genomic sample, run it through the genome code, connect it to the clinical data, and be able to see if this patient is more likely to develop adenomas, and bring them back in 6 months as opposed to 1 year for another screening. So this is possible. This improves the quality of the care, while at the same time keeping the cost down. Because if a patient comes to the institution after the fact, after they have already developed a tumor, so for example, it is very costly for the patient care. But if we can prevent it, we believe it will be cheaper. So that's where I think we are using a lot of machine learning to be able to detect diseases before they actually happen. And one other use case that we are very interested in working with some of the people who provide us weather, latitude, longitude data is to be able to collect. There are some diseases that we have studied in the patterns that they're very seasonal. Depending on the time of the year, a recurring pattern happens in the diseases and patients come to the ED. So we are able to, say for example, monitor what is the allergy count in the environment for any given day and be able to source proper resources in the ED. We are able to do this now because there are now trained models that are able to see and correlate the weather data with the actual patient data.
Yeah, that's good. I know one of our customers is using EPA data.
Yeah.
And asthma is one of the prime reasons why people end up
Exactly.
in the ER, yeah.
That's a great example of correlating the weather data with the patient's clinical data.
All right, so I think we have time for one more question, and then we'll wrap up for the morning. So I'm gonna. Do you want to keep going? Well, let's do the audience hands. All right. And as Christine mentioned, all the panelists will be available for questions after we wrap. So I'm going to start with Ginny, and then we'll work our way back. So final thoughts. In your experience, what are some of the biggest challenges and opportunities when adopting or building your own platforms and frameworks?
Well, so the opportunity is to be able to address use cases we couldn't do before and to be able to process data that we couldn't successfully process. We had a recent experience with a client, and their analyst was spending all morning, so 4 hours a day, looking through a set of data, looking for correlations.
And he would get through about 30% of his data, and then after lunch, he'd have to get on with working with the correlations. And in the space of about 9 days, we built a very simple system based on Scape that actually processes 100% of that data in 9 seconds. So we gave him back 3 hours, 59 minutes, and 51 seconds, and we identified a far higher number of correlations for them to look at. So I think the opportunity is we are freeing up some very brilliant people, the analysts in the intelligence community and other domains. We are freeing them up to think about the hard parts of the problem, the parts that we're still trying to tackle with computer science, where human brains are just so far ahead. For the challenges, there are a lot of challenges for us around security. I guess you wouldn't be surprised to hear that. Both keeping the data secure and also this idea of access to the data. And way back at the beginning, there was the statistic about 70% of people are getting to data that they shouldn't have access to. That can't happen in our environment. So our historical approach had been just lock it all down and lock down a record at whatever the highest piece of data, or the classification of the highest piece of data in there. And now we have the ability to be much more precise about that. For example, we do a lot of tracking to identify potential locations of improvised explosive devices. How we determine where they are is very sensitive information, but where they are is incredibly unclassified, and we want to get that out actually to the widest collection of warfighters we can, so they don't stumble across them. And so we were able to use some of the specifics in our Hadoop instances to track security and access all the way down to the cell level, so that we can give people only the people who need access to the background information have it, but we can actually push those IED notifications all the way down to the Humvees in the cars. The other challenge for us is often about scale, and it is about modernizing. So there's a lot invested in infrastructure that's already there, and it's an aircraft carrier, right? It's not a powerboat. It's a big shift to make that move. Lineage of the data is also really important to us too. This idea that if we come to some conclusion, it's based on lots of pieces of data, and we need to know what all those pieces were, so that if down the road we have less confidence in some of those pieces, we understand what the impact is to the recommendations we've made. So that is an area that we continue to explore, and an area where Cloudera in particular has been really helpful. We have leveraged a lot of the Cloudera capabilities to help us preserve that lineage as data moves through our systems.
Thank you, Jenny. Brian?
Yeah, I think the greatest challenge is also the greatest opportunity going forward, and it's actually one more of on the softer end of things. It's leading people and trying to change the culture of the organization, because if you talk about machine learning and all these capabilities, individuals in the organization, leaders in the organization, they can get really scared that, great example with that analyst. In that case, are they concerned that tool is taking away their job? And it's an issue of how do they define themselves? Are they an analyst that's going to do work manually, counting tanks on imagery, or the notion of AI coming in and counting everything, and it allows that person to do much more interesting, much more difficult work that's not so manual, not so much tedious. So I think from my standpoint at USGS, similar challenges, just with the notion of making our IT staff comfortable with some aspects of their job going away, that, the developer can just spool up capabilities as they need. And, people redefining their roles and enabling that, and really kind of creating a safe space and making sure individuals in the organization are not risk averse.
We've seen a lot of organizations having to develop new relationships with HR because the traditional career paths no longer apply.
Right.
Have you done some certain things in that area?
A lot of it is just messaging. I will bring up the interesting fact that I'm a government employee, and I've got pretty much a permanent position within government. And so it's interesting, whether I was at NGA or USGS, there's a bit of a fear factor with government employees. And I always think, gosh, if it's so difficult to get rid of a federal employee, and some of the stories you'll hear will be really negative, but I like to flip it and think about the top 95%, and why don't we use that permanence to release people, to innovate, figure things out, because the average startup would kill for that opportunity. I've got a guaranteed paycheck. I'm going to have one next year too. I might get a promotion, I might not, but I've got a guaranteed opportunity. So let's use that, and not just me, but everybody in the organization. Let's use that to innovate. Let's use it to learn. We can fail and figure things out. Fail quickly and figure things out. And whether it's leveraging the cloud, leveraging new capabilities, and let's re-identify ourselves and what our role is in the organization. It may not be an analyst anymore or an IT person that literally builds hardware, So I think going forward, again, for me, that's like the number. There's all this disruption, and it's a fantastic opportunity. The challenge is getting people to understand that it'll work out.
That's fantastic and a very refreshing perspective. Thank
Yeah.
you for that. Yeah. Jawad?
Sure. It's hard to be at the tail end of a common question because the guys have covered everything. But I'm going to provide, in the context of my work, pretty much relate to exactly what was said in the context of what we are facing with. Our challenges obviously were resources. First of all, get resources to make sure the resources are assigned for doing any innovative work in the big data space. The second was to be able to then bring in proper human resources. You would need a proper team, the right team, with the right size to be able to get the work done. And then the third was exactly what Brian said, I think, to have the institution accept the change. Because it's not easy. And for a university like ours, which is very patient safety focused, patient first mentality, it is very hard for them to think of it innovatively, because they're always concerned about quality of the patient, right? So these were the challenges that we had to do, soft challenges, if you may. And then there are technical challenges. The institution really can't do away with the sunk costs in the technology and the implementation that is already in place. It's not like we were not able to do things with the small data, with the data warehouses, with the ETLs that were in place. Things were getting done. We were still able to provide insights. But with the ability to do big data, with the ability to innovate, we are providing better results faster, right? That has been addressed, faster. Take away all the friction between the users who want to consume the data and the data itself. That is exactly what the story was when we presented to the institution, to say that we want to do things in a way that there is no friction. If you want access to the data, there is no reason why you have to wait for 24 hours for the ETL to finish and then a report be generated for you to consume the report. There is ability and technology now available that you can view the data as it is happening in the hospital. There could be a command center, there could be a dashboard that can give you insights into what's happening in the institution in real time. This story, I think, is compelling in itself, except that it has to be presented in a way that people are able to do it and work with it. So challenges were a lot, but I think you said, challenges are the best opportunities, and we were presented in a way that it made sense, and so far, it's a success story at our institution.
That's great. Well, thank you guys so much. It was really insightful, and as we said, we'll all be around here for a little while, so if you guys want to have some smaller conversations, that'd be great. Thanks for everyone for joining us.
Thank you.